Let's have a look at this displacement time graph question from 2019. We've got an athlete running along a straight horizontal track during the time interval 0 to 8 seconds. The displacement relative to the origin is modeled by the displacement time graph, and we've got this curved shape here. What we're going to need to do is determine the total distance traveled and the average speed. We're also going to need to find out the times when the athlete is instantaneously at rest, and we're going to need to write down some time intervals where the velocity is negative, and this other one down here where the velocity is increasing and the speed is decreasing. Pause the video to have a go yourself. You'll want to try and spend about 5 to 7 minutes on this problem in total. Unpause the video when you're ready to have a little look at the answers. Okay, let's try part A first. We're going to look at the total distance travelled. Now, to do that, we need to just split it up into several parts. So this first little chunk of journey here, we're travelling 16 meters in those first 4 seconds. The next little part of the journey here, we're going back 16 meters, but it's still an extra 16. The next little bits of journey, we have got the athlete going down 9 meters here, and then finally they go back to the origin, which is another 9 meters again. So the total distance traveled is the sum of all of those values, and that should come to 16 plus 9 is 25, so I'll double that to give me 50 meters. The average speed calculation, I'm going to need to divide the total distance by the time. So I'm going to divide 50 by 8, give me an average speed of 6.25 meters per second. For these other bits, part B, write down the times where the athlete is instantaneously at rest. Let's just clear up my diagram for a moment. When the athlete is at rest, the gradient of the graph should be completely flat, and that happens in 2 places. And it is indicated in the question, it does say times. There's one instance here at 4 seconds, and another instance here at 7 seconds. For part B, I've got t is 4 and t is 7. Finally, we've got part C, and there's 2 sections to this. The first is to say when the velocity of the athlete is negative, and that is this stretch here from 4 to 7 seconds. So we can see that the velocity is negative when the gradient of the line is negative. I should probably put these type of inequalities, because technically at 4 and 7 it was flat. Finally, part 2, this is a little bit trickier, this, a little bit more nuanced. The velocity is increasing, the speed is decreasing. So the athlete is getting slower, but the value is getting more positive. And so we're actually looking at this region here between 6 and 7. So you can see the slope is getting less steep. So a velocity is going from a larger negative number at 6 to a smaller negative number as it levels off. And then by the time we get to 7, it's got to 0. So our velocity is technically increasing while the speed is decreasing in that period there.